Okay, I'm live here with 52 weeks of Swift language. I'm continuing to go down the language guide. And today I'm going to cover a really cool topic, which is for loops in Swift. And I mean, just in general, one of the things that's interesting about all of the Swift, uh, language guide information is just how amazing it is in relation to Python. Because on one hand, it's got all the good stuff that Python's got, but it doesn't have all of these problems that Python has. For example, it's performant, right? That's one of the biggest ones. It's got a great IDE. It has a compiler. The concurrency problems don't exist there because you can use native threads and all of these great characteristics. So there's a lot to like if you're a Python programmer and you're doing things with Swift. And I'm going to go ahead and share my screen here and get started. And let's go ahead and do that. So share screen, go to window, and we can go to screen 2 here. Perfect. So in a nutshell here, I'm going to start with this language guide again. Control flow is the section I'm on. And in particular, what I'm going to dive into is, how do you make things happen in the Swift language? And in particular, for loop is always the place I think that's a great place to start. Let's go ahead and take this first phrase here, which is a list definition. In fact, I'm going to just throw this over and make it a little bigger. So we've got a let names here. So I have an immutable list or array called names. And so how do I pull things out of it? Well, fortunately, it's pretty straightforward. All I need to do is do this for loop. So I can say for name in names. If you're familiar again with Python, this is very common type style, and we'll just print a hello, and I'll say hello. And then for string substitution, pretty simple in Swift, use this backslash, and then you substitute the variable. In this case, this is the loop variable name right here, and then I can put whatever I want, maybe 2 exclamation points. If I do a return, shift return here, there we go. We got our information. So really very, very intuitive, in my opinion, to do a for loop in Swift. You could teach a first grader, if they've got a little bit of programming experience, how to do a for loop. Now, a couple things to point out are that if we have something that's slightly more complex, like a dictionary, and so in this case, we can see that we have a dictionary here. I'm going to go ahead and pull this in. And so in this case, this will be the key value pairs, right? And so if you're familiar with dictionaries, you know that you need to pull the key value pairs out, right? You want to do something with the key and do something with the value. So how do I do this? Well, you can just do a for loop that pulls the key out and the value out. In this case, we'll do that, right? So I'll say for, and I'll say animal name, and I could do animal name here. Let's do this, build this out, and then we'll also put another loop variable, which is count, and we'll say in, and we can just do a tab completion now because the compiler knows that exists. And I can do a return. So basically, for animal leg count in number of legs, I can just do my print statement. So we'll say print, and I can just go through here, do the same thing, the backslash for substitution, and then I'll put in my loop variable. In this case, I'll want to pull the key out first, be the animal name, and we'll say animal name, which is that one, and then we'll do have, and we'll do the same thing, backslash, and leg. Here we go, leg count tab. Because I still have a gimpy finger here, I might try to do some cut and paste here until this thing is completely healed up. I have a little bit of surgery finger here still. So that looks like it works out great, but the key takeaway is animal and leg count, which are key value pairs. So the next thing that I'm going to do is go through and do a for loop where it actually has a range. This is also really common. Let's say you wanted to create 5 files, right? How would you do it? Well, you could just give a range. That way you don't have to do anything fancy. It's just kind of built into the language. So really, really common trick to do. So in Swift, you just say for index in one dot dot dot, and then that gives us actually the range here. And then I can multiply that loop variable by 5, right? If I want to do something tricky. So if I wanted to do something bigger, right, I can do 50. It should make an explosion, right, of new values. So pretty straightforward to do ranges here. Okay, what if we want to do some kind of accumulator, right, where we basically throw away the loop value, and then we go through here and we accumulate. This is also very similar to what I would expect in the Python language. Let's go here and let's play around with this. So we have a let base immutable variable, let power immutable variable. We have immutable variable answer. We throw away the loop variable and we say basically for every iteration, we want to do a power. And so we're going to say print 3 to the power of 10 is 59049. So let's go ahead and run this. There we go. Pretty neat. And if in this case, it says in some situations you may not want to use a close range. And so maybe you want to draw 60 tick marks starting with 0. And so you can do this. You can say let minutes equal 60. And you say basically do it under. That's kind of an interesting little loop there. So this one will render out every for tick mark in 0 minutes. Let's run this again. Let minutes tick mark in minutes. So immutable variable tick mark was never used. Consider replacing it with not sure why this is giving us issues here. I guess we would want to say a print to make it do something useful. We'll just say print tick mark, something like that. We'll do this tick mark. There we go. This should work. There you go. Yeah. So it didn't like it that there wasn't something inside of here. So this is more pseudocode. It's not actually completely executable. You would need to put a print statement in these loops here. So yeah, it's neat to have these additional kind of range-based loop things here. Okay, next up, I'm going to play around with a while loop. Also, a classic thing to do is to build a while loop. In fact, one of the best use cases of a while loop is to build a server, right? If you want to build a daemon or some kind of process that's running forever, you could build a while loop. And so, in general, the while loops are going to be a while something, while true, do this thing. And in particular, it looks like there's a game they want us to play. So let's go ahead and put this together. We'll build this out. We'll go ahead and throw this in. And so this says let final square, and then create a board right here. We've got this set up here. You can see this on the right over here. We've got this board. And this says some squares are set to have more specific values for the snakes. So we can go ahead and create some board values here next. Go ahead and run that. And then we can actually build like a little game here, which is kind of cool. And here we go. We'll build this game out. So the idea here in this scenario is that this is, people use while loops to do something until a condition's met. It could be forever, or it could be, in the case of a game, the situation is met, and then you go through and you say, okay, it's time for the game to be over, because I think it's when it gets to 10, the game is over, I believe. If square is less than board count. So it looks like it was incremented enough and it decided to quit. So you could also do repeat while, which is a single pass through, and then it continues to loop until the condition is false. And so here's another kind of game we could play. So we can go ahead and build this. There we go. And here we go. We can go ahead and build this. Perfect. And there we go. And now if we want to go through here and say some conditional statements, this might be another thing that we could do. So we could say, essentially, let's make an if statement. Here we go. If var temperature, it's very cold, consider wearing a scarf, right? So these if statements are also very similar to other languages. It's really just meeting a condition. If else, here's another one. We just say if this, then we go to this, right? So we can go through here and print out, some other statement. You can also chain multiple conditional statements together, right? We go through here and we chain this together. So, I mean, these are a little bit messy, like any kind of conditional. I think one of these variables is missing, but basically, a conditional statements, if else, elif, those are pretty common. Not too much fun to take a look at. I think it's a little more fun to play around with actually a switch statement. So a switch is actually a much cleaner way to do conditionals because you basically just switch between the conditions that you want. And so in this scenario, we say let some characters right here, we say switch some characters, and we say in the case of A, print this, in the case of Z, print this. And so let's go ahead and print this whole thing out here, the last letter of the alphabet. So in this case, the sum character was Z. So when it rolled down to here, it printed out that variable. So pretty cool actually to use the switch statements. In fact, they're not available in some languages, but they are very, very handy in terms of doing things. So in this case, this says this will report a compile time error, and the reason why is that each case must contain at least one executable statement, and that's the real issue with that particular statement. So if we go through and we switch this, and we go through here, and we build this out, this should fix that. There we go, letter A, and we're able to switch this out because we say the character is A, and we say case A, and it's able to determine that it's able to read through the case statement. So you can also do intervals as well with case statements. In this case, we're going to say this number uses number intervals to provide a natural language count for numbers of any size. So that's kind of a neat way to do ranges. And you could see this could be great for some kind of logic, in an application. I could see myself doing a bunch of these ranges inside of here. There are dozens of moons orbiting Saturn. Tuples. So you can also do case with tuples. So you can test multiple values in the same switch statement. In this case here, we can go through and we can say case, and then try out these multiple case statements. There we go. Let's paste. Let's copy this in and do this. So this is kind of cool because this allows us to basically look at these tuples and then compare those. Let's see what else we could do. A switch can also name the value or values it matches to temporary constants or variables. And so in this particular example, we say case let x0 print on the x-axis with an x value. So that's pretty cool. We'll go ahead and do that and delete that, put in perfect. There we go. Now we can also do where clause. So a switch can also use a where clause to check for additional conditions. And so in this case, we would say let another point switch yet another point, and then we'd say where x is equal to y, right? So that's kind of neat, is that you can actually use a little bit of, SQL type style flavor to these, which really is pretty nice for doing things like coordinates. So compound cases, multiple switch statements that share the same body can be combined by writing several patterns after case. And so in this case, there's a comma between each pattern here, which is pretty cool. So in this case, the patterns can be written over multiple lines. So it is pretty nice, actually, how we have so many of these kind of, patterns that you could use with doing switch statements, and especially compound switch statements. So we also have control transfer statements. So these are really common too. If you start to build some kind of more sophisticated for loop, sometimes you want to say continue, right? Like you basically don't exit the loop, but just don't do the thing below me. There's all kinds of really cool transfers that you can do. So in this case, continue tells a loop to stop what it's doing, but just go back again through the loop. Don't completely exit the loop. So it's like partially exit the loop, just exit the sub loop essentially with a continue statement. So we can go through here, run this out. We can say for character in puzzle, if character.remove contains this, then just go back up to the top. Otherwise, put this inside of here. So I do like continue statements. I think they're pretty cool. Break statements are also nice, basically to break out of something. In this particular scenario, you could just say, hey, let's do all this stuff until I need to break. And then you go through and you would break out of your statement here. And then we can do fall throughs as well. This is a good example of a fall through. There we go. Perfect. And so really in a nutshell, there's a lot of sophistication with all of these different loops. So in a nutshell, if we scroll down here, we've also got some board game values here we can play around with. Those look pretty neat. We could do a more sophisticated while loop, switches, all kinds of really cool logic. I won't run all of that. But what about early exit? This is kind of interesting. So a guard statement, basically to require a condition must be true in order for the code after the guard statement to be executed. So basically, this kind of gives you some additional protection here in this function. So this guard says at the very end, let location personal. I hope the weather is nice near you. That's also kind of a neat little trick there with the Swift language that I haven't seen before in the past. Really more of like a functional style that you see here with the guard statement. And you can also check for API availability. So another one that you can do is Swift has built-in support for checking API availability. And so that is actually pretty cool. So if we go through here, I could see how this could be a neat little trick. If I say if available iOS 10, Mac 10, 10, right? Otherwise fall back. So that's kind of built in. Yeah, having built-in if else statements that can check for the API call is definitely pretty cool. So yeah, I guess in a nutshell here, let me just stop sharing my screen. I was able to go through and just check out and play around a little bit with if else statements. And what was really cool about it was that it really is pretty intuitive. And then there's also new features like case statements and switch statements, which I think are pretty neat. So I hope to see you next week. I'm going to keep going. Next week, I'm going to cover functions, which should be really cool. All right. See you next week.